Alright, this is question number 11 from lesson 2 homework. I'm going to do A, and I'll leave B and C for you guys to try on your own. So it says determine whether the following sets of vectors form basis for three-dimensional space. And then if it does, determine the coordinates of V relative to the basis. So this is really a two-part question. It's really an A part, forms a base for space, and then B, find a linear combination of. So definitely, it's a larger question. So in order to find a basis of space, that means that we need to determine V1 cross V2 dot V3 to see what that's going to result in. So we're going to have to do a cross product here. So do that off to the side here. Hopefully I can do this properly. 1, 1. So the cross product here would result in 0 take away 1, 2 plus 1, negative 1 plus 0. So hopefully I did that cross product properly. And now I'm going to have to dot it with that. So we'd end up with negative 3 plus 3 minus 1, which is equal to negative 1, which tells me that this is a basis of space. So therefore it is a base of space, or base for space. And we know this if it was 0, if this resulted in a 0, it would tell me it would be coplanar. So as long as it's not equal to 0, we have a basis for space. So I'll leave that. So there we go. So A part's answered. Now, B part. What do they want me to do for B part? They want me to determine this equation. AB1 plus BV2 plus CV3. So they want us to determine the linear combination of V1, V2, and V3 to give us the vector V. And we can do this because it's a basis of space, so that means we can move in any direction that we want. So just as a quick reminder, piece of paper, if vector V is in fact off the page, all right, we know that because these vectors are not a basis of space, we know that at least one vector is off the page, so that'll allow us to get from our desired point A to point B. Okay, now the tricky part. So vector V is 1, 2, 3 multiplied by A, which is negative 1, 0, and 1. Vector B, or sorry, the V2 is 2, 1, 1. And C is 3, 1, 1. So now we are going to end up with 3 equations, 3 unknowns. So if I do the x component first, plus 2b plus 3c, y component, 0a plus b plus c, and then the z component, which is a plus b plus c. So there I stacked them, keeping my A's, B's, and C's in line. I'm going to tell you right now, the questions in this homework section are set up so that you can solve them through elimination fairly easily. There's going to be people, and the reason for that, let me talk about the reason. The reason is because there are zeros, or at least 1 0, appearing in the initial vectors. If that value right here was not a 0, this question would become twice as hard as it is right now. So you're asking me right now, well, what happens if it isn't a 0? You're playing the what if game. I'm gonna give you a process in which to make it easier, and a little bit later on, if you look ahead, there's a lesson on matrices. It's not part of the vector curriculum or the grade 12 curriculum. However, it's something that you're going to use first year university, and I have students come back saying that that's one of the most important things they learn, because it's a process that allows you to solve this mess easily without having to do elimination 3 or 4 times. All right. So for the homework right now, we can use elimination here, because if you take, for example, the bottom 2 equations and I perform subtraction, both the B's and C's will cancel out right away. So 2 take away 3 is negative 1. 0a, just be careful here, 0a, take away a, gives me negative a, and the b's and c's cancel, so therefore a is equal to 1. All right, that allows me then to go back and plug in the other information, so I'll do that. So now I'm going to have my, let's go with the first equation. So 1 equals negative 1 plus 2b plus 3c. The second equation is 2 equals b plus c. I'm just going to move down. So I took those top two equations and I replaced a with negative 1. So it moves to the other side. So I'm going to cross it out and make that a 2. Now I'm just doing elimination because I have two equations, two unknowns. So I'm just going to double the bottom equation. So I have 2 equals 2b plus 3c. I have 4 equals 2b plus 2c. To get rid of my b terms, they're the same sign, so I'm going to have to do subtraction. So negative 2 equals c. So c equals negative 2, which will then allow me to find b. So I'm going to take that bottom equation. 2 equals b plus c. 2 equals b minus 2. So b is equal to 4. So therefore, final answer, that v vector can be determined by taking vector v1 plus 4 times v2 minus 2 times v3. So those coefficients that we just found, the a, the b, and the c value, they become the 1, the 4, and the negative 2 in the equation. And that's how you'd write up your final answer. For myself, I know the book does it a little bit different in terms of the solution, but that is what we're looking for. So, yeah, it takes, just like I said, this is a monster question that they've given you. If we were using matrices, you're going to ask me, you know, is there a quicker method to do this? Absolutely, and that's why I do the matrices, because if you do a couple of these in the homework, you're going to realize that it does take a little bit of time. So, like I said, the ones in the homework, because there's zeros in the initial vectors, you can do it through elimination. And then once we get to matrices, you're going to see a bigger shortcut that make life a lot easier. So anyway, there you go. If you have any further questions or you have troubles with B and C, let me know, and I'll help you with that.